The United States just changed the rules for fusion energy, and it could accelerate the race to unlimited clean power. The United States has taken one of its biggest steps yet toward making fusion energy a commercial reality. For decades, fusion has been called the energy of the future. Scientists have pursued it because it promises something extraordinary, virtually limitless clean energy with no carbon emissions, no risk of a catastrophic reactor meltdown, and far less long-lived radioactive waste than today's nuclear fission plants. But despite enormous scientific progress, there has been another major obstacle standing in the way, not just technology but regulation. Until now, many fusion companies were being regulated under rules originally designed for nuclear fission reactors. Those regulations were created for power plants that split uranium atoms, produce large amounts of long-lived radioactive waste, and require extensive safety reviews because of the possibility of core meltdowns. Fusion is fundamentally different. Instead of splitting heavy atoms apart, fusion combines light atoms, typically forms of hydrogen, releasing enormous amounts of energy, much like the process that powers the sun. Fusion reactions cannot run away into a meltdown, and if something goes wrong, the reaction simply stops. While fusion facilities still use radioactive materials such as tritium and require careful safety measures, their overall risk profile is significantly different from that of conventional nuclear reactors. Recognizing those differences, the U.S. Nuclear Regulatory Commission has proposed an entirely new regulatory framework built specifically for fusion. Rather than regulating fusion plants as if they were fission reactors, the new approach focuses primarily on safely managing radioactive materials like tritium, radiation protection, waste handling, and eventual decommissioning. Instead of requiring years, or even more than a decade, of reactor design reviews, developers could receive licenses in a matter of months to a year, dramatically reducing the time needed to move projects from the drawing board to construction. This doesn't mean fusion companies can ignore safety. Far from it. They must still demonstrate that radioactive materials are properly contained, workers and the public are protected, and facilities can be safely shut down and dismantled. The difference is that regulators are now focusing on the actual hazards fusion presents instead of applying rules written for a completely different technology. The change follows the Advance Act of 2024, which established that fusion devices should be regulated more like particle accelerators than traditional nuclear reactors. Many companies in the industry argued that this distinction was essential if commercial fusion was ever going to become practical. Fusion developers have welcomed the new framework because it finally provides something the industry has lacked for years: regulatory certainty. Instead of wondering how a first-of-its-kind fusion power plant will be licensed, companies now have a clearer path for bringing designs to market. That clarity makes it easier to attract investors, secure financing, and plan commercial projects years in advance. Several major American fusion companies, including Helion Energy, Commonwealth Fusion Systems, TAE Technologies, and Type 1 Energy, are already building demonstration systems and planning pilot power plants. While none are yet supplying large amounts of electricity to the grid, many hope to begin commercial operations during the early to mid-2030s if both engineering and regulatory milestones continue to be met. It's important to understand that these new regulations don't solve fusion's biggest technical challenges. Scientists still need to achieve sustained, net-positive fusion reactions, develop materials that can withstand the extreme conditions inside a reactor, create reliable fuel systems, and build reactors that are practical and affordable to manufacture. Those remain enormous challenges. What the new rules do is remove one major non-technical barrier. Instead of waiting years for licensing uncertainty to be resolved, companies can now focus more of their effort on solving the engineering problems that stand between today's prototypes and tomorrow's commercial power plants. If fusion succeeds, the impact could be transformational. Fusion power plants could provide continuous electricity day and night without emitting greenhouse gases, complementing renewable energy sources such as solar and wind. They could power AI data centers, desalination facilities, advanced manufacturing, and future electric grids while reducing dependence on fossil fuels. Commercial fusion is still not guaranteed, but with scientific progress accelerating and a regulatory, each sentence can be long if the input requires it, but must not exceed 30 words. If a sentence is longer, split it into 2 or more natural sentences without altering the content.